Even though it is not at fault in any way, the James Webb Space Telescope could make big mistakes when it looks at planets where alien creatures live. This is the conclusion reached by researchers in a recent study that looked at the models that scientists use to analyze data after the Webb telescope makes an observation rather than the optics of the Webb telescope. According to Prajwal Nirala, a graduate student at MIT and co-author of a new research paper published on Thursday in Nature Astronomy, the models that scientists use to describe opacity, which refers to how readily light goes through an atmosphere, are not precise enough. Because Webb studies exoplanets, planets that orbit stars other than our Sun, by measuring the wavelengths of light that pass through a planet's atmosphere with its spectroscopic instrument, the less accurate models may suggest that Webb telescope measurements are an order of magnitude off from reality. At present, the model that we use to decode spectral information is not up to speed with the precision and quality of data that we have from the James Webb Telescope, Nirala said in a news statement. The opacity problem demands all of us to stand up and work together to find a solution. The spectrometer instrument aboard Webb is in charge of acquiring a spectrum, which is a collection of distinct wavelengths of light created when light travels through the atmosphere of an exoplanet. Because various molecules absorb light at different wavelengths, a spectrum's characteristic pattern may inform scientists what substances are present in what amounts in a planet's atmosphere. Some of these chemicals are gases and organics, which could mean that there is life on the planet. If the opacity model problem isn't fixed, scientists might miss signs of life on an exoplanet or get a false positive when looking for signs of life in the atmosphere of an exoplanet. One of the study's co-authors, Julian DeWitt, an assistant professor in the Department of Earth, Atmospheric, and Planetary Sciences at MIT, stated in a press release that there is a scientifically significant difference between a compound like water being present at 5% versus 25%, but that current models cannot differentiate between the two percentages. The researchers created other opacity models for the sake of their investigation. These simulations altered critical assumptions about how light and matter interact in an exoplanet's atmosphere. They then ran the Webb spectra through these models and discovered that each model produced very different results from one another, but that each model also seemed to fit the data very well. Scientists looking at that data would find it difficult to know that it was incorrect. To put it another way, unless they knew what to look for. We observed that even with a defective model, there are enough parameters that may be changed to get a good match. This implies you would be unaware that your model is incorrect and that what it is saying to you is incorrect. Dr. DeWitt remarked. The researchers have proposed a variety of improvements to opacity models in order for them to match the degree of accuracy afforded by Webb's optics. For example, more laboratory experiments might be used to ground models, models could be improved, and astronomers could benefit from a centralized database with consistent formatting to let them update their models based on spectrum data and experiments. These are just a few instances. Mr. Nirala believes that if we completely knew how light and matter interact, there is so much that could be done with that knowledge. We know plenty about the Earth's conditions, but as we go to other kinds of atmospheres, things change, and there's a lot of data, with increasing quality, that we risk misinterpreting. We all know that one day our beautiful sun will stop shining, so here's a question. Do you think that in the distant future, humans will be able to continue their existence on another exoplanet that is habitable? Please leave a comment below, and while you're there, like and subscribe to the channel.